Welcome to this video where we're going to be looking at steel testing, in particular checking Brinell and Vickers hardness. Hardness testing. When it comes to testing the hardness of steel, there are different methods that are used to suit the steel grades you are testing. The different test methods are Brinell, Vickers and Rockwell. In this video we'll be focusing on Brinell and Vickers hardness testing. Before we jump into details, let's have a look who this video is really for. The hardness of steel determines how much it can resist deformation and abrasion. Understanding Brinell and Vickers hardness testing of steel and what applications they are used for is an important factor for any design engineer. So let's jump straight into having a look at Brinell hardness testing. Now the Brinell test is carried out with a steel ball of 2.5, a 5 or a 10mm in diameter as the indenter. The loading force for testing steel is 30,000 newtons. The Brinell number is calculated using this formula. In order to eliminate an influence of the specimen supporting the base, the specimen should be at least 7 times the thickness that of the indentation depth. The Brinell hardness test method is used to determine Brinell hardness. This is defined in ASTM E10. Most commonly, it is used to test materials that have a structure that is too coarse or that have a surface that is too rough to be tested using other test methods. For example, castings and forgings are a typical product that uses the Brinell hardness test. Brinell testing often use a very high test load, 3,000 kilogram force, and a 10mm diameter indenter, so that the resulting indentation averages out most surface and subsurface inconsistencies. Now, typical values for the Brinell hardness with mild steel, it's around 120, 304 stainless is around 200, and hardened tool steels is between 600 and 900. Previously, we talked about the Brinell hardness calculation and using a 10mm diameter ball. In reality, the calculation is not used on every test. Instead, a set of standard tables is used to look up the indentation diameter, against which would have a hardness value. The test force must be selected such that the average indenter diameter is between 2.4 and 6 mm. So the average indentation diameter is worked out using this calculation here. If we look down the HBW 30 and the 10 3000 range, we can see the value for mild steel, which is around 121. This has an indentation average of 5.39. Let's have a look at the Vickers hardness testing. Vickers testing is similar to the Brinell test method, but it only uses the diamond indenter of 136 degrees square base pyramid. The impression produced by the Vickers indenter is cleaner than the Brinell indenter, therefore the Vickers test is more accurate. The load, varying from 1 kilogram force to 120 kilogram force, is usually applied for 30 seconds. The Vickers number, or HV, is calculated by this formula, where F is the applied load in kilograms and D is the length of the impression diagonal in millimeters. You can see an image of that here. The length of the impression diagonal is measured by a microscope, which is usually an integral part of the Vickers test machine. Vickers hardness numbers are shown as XXX, HV, dictating hardness Vickers, and YY. For example, we've got 440 HV30, or we've got XXX HV YY / ZZ. If the duration of the force differs from 10 seconds to 15 seconds. For example, we've got 440 HV30 / 20, where the 440 is the hardness number HV is dictating the hardness scale, which is Vickers. 30 indicates the load used, a kilogram force, and 20 indicates the loading time if it differs from 10 to 15 seconds. If it was the standard 10 to 15 seconds, you wouldn't have that /20 added on. So some typical examples of the materials with the Vickers Hardness test results are here. So we can see it's the 316L stainless steel has 140 HV30. The 347L stainless steel is slightly harder, which is 180 Vickers 30. Carbon steel, which is between 55 and 120. And iron, which ranges between 30 and 80. In reality, the calculation is not carried out on every single test. Instead, a set of standard tables is used in order to work out what the hardness value is based upon the average indentation. Now, the average indentation is just worked out taking the averages of the two vertical or horizontal lines. So, as an example, we can look at the indentation of 0.108 millimeters or 108 microns. We could do that by looking down the column here indicating 1. So if we look down on the microns and find 108, we can then cross-reference that, and it's got a hardness value of 160. So don't forget to click the like button if this video was helpful. Thanks for listening. My name is Paul Adams from Sofeast, and I shall see you in the next video.